Welcome everyone. So I do not know lots of faces. I do not recognize any faces in the room pretty much, which for me is really nice because it means that today you are all going to learn about things that you may have not heard about before. So I'm really happy that we could arrange for this for today's workshop. Well, before I actually get started, I wanted to thank already the organizing team, and Zach has been really helpful in making this happen. Thank our speakers. Many of them come a long way, all the way from San Francisco, from London in the UK, I come from France, as you may hear and recognize from the accent. We have people from Netherlands. It's going to be a great day. So I don't know how much you know about open source IoT, how much you know about Eclipse IoT technology, but in any case, I know that I will learn a lot today, so I'm sure you will learn as well. Make sure you check out the program for today to not miss any sessions that you're interested in case you want to check out the other workshops. But yeah, we're going to talk about all things MQTT, about fog computing. We have several speakers from Bosch. We're going to talk about real hands-on case studies on how they are actually deploying IoT solutions today. So yeah, very much looking forward to the day. Feel free to tweet and to share your thoughts on your social networks. We have plenty of time for questions at the end of the sessions. We have plenty of times during the breaks and during lunch for socializing and for networking with the speakers or among yourselves. So I hope you will make use of this quality time as well. Like Zach said, it might get packed. So yeah, there's a few seats over there. And I think we're going to bring some more chairs as well. So how about we get started? So I thought I usually don't like or try to avoid speaking at our conferences, but I figured that once in a while it's actually useful to take a step back and give an overview of what's going on in the Eclipse open source community, because, well, there's quite frankly a lot. We have lots of companies involved, lots of open source projects. Some of them will be represented here today, some of them might not. So kind of a state of the union of the Eclipse IoT community. How many of you would say they know Eclipse IoT? They've heard about Eclipse IoT. There you go. So that's what I thought. You're going to learn a few things. The Eclipse Foundation, anyone? Okay, a few more hands in the air. So yeah, Eclipse IoT is an open source community that is part of the Eclipse Foundation. So there's quite a few open source foundations out there. The Linux Foundation, the Apache Foundation, Mozilla, and a bunch of others. And what open source foundations do is basically help people and companies collaborate on open source software and open source business models. So what does it mean? Well, for the automotive industry, for example, there's lots of software that needs to be put within a car that's not really differentiating in any ways. And quite the opposite, actually. It's in everyone's interest in the industry that there's some open standards and common software building blocks that everyone shares, so that like pretty much everyone across the supply chain can start building value on top of like common standards and common software building blocks. And this is something that's happening in many industries, not only in automotive, obviously IoT, but like companies like Boeing and Airbus, they try to collaborate as well on like common tools for managing the requirements and managing all the traceability they require in their again in their own supply chains. And so the Eclipse Foundation is really one of those communities, and we've been around for 15 years pretty much, one of those communities that help make that happen. And in practice, how does it work? Well, we are a not-for-profit, and we are like driven by our community being individuals and people who work on open source technology and who actually like develop and collaborate on open source software. And beyond like the technology itself, it's also companies. The companies are actually members of the Eclipse Foundation. We have close to 300 member companies. And they work with us and we work with them to make sure that there is a sustainable business sustainable model and sustainable ecosystem around all those open source technologies that they care about. And so how does that happen? Well, it's essentially member companies and individuals providing manpower, if you will, to work on the actual technology, but it's also professional staff on the Eclipse Foundation side, and people like myself and my colleagues who help put together conferences, like today's conference. We help put together all the resources that one may require to work on open source software, so all the bug trackers, the source code repositories, etc. And that's what the Eclipse Foundation do, and again, does. And again, that's similar to other other open source foundations out there. And you may think, well, open source, I know open source, like GitHub is about doing open source. Yes, it is. It very much is. But the main difference with a foundation like the Eclipse Foundation or Linux Foundation is that we are really meant to enable like commercial ecosystems around open source. You go on GitHub, yes, you can collaborate with your peers and with other software engineers on open source software, but there's lots of things that are sort of not addressed by the GitHub collaboration model. How does it work when it comes to managing the intellectual property? Yes, it's open source, but who actually owns the copyright of the code? Who owns the roadmap, if you will? Who is actually in charge of the future of the project? Is there really a level playing field on your GitHub open source project? Chances are there's not, right? So a foundation provides really the framework, the legal framework for managing all the intellectual property, the framework in terms of what's the development process that all the companies and all the individuals working on the open source projects are expected to follow, and provide all the guidance, if you will, to make sure that the projects are successful as open source projects. And beyond that, success is also being successful in terms of commercial adoption. So for us, we very much encourage like people to take our open source projects and to build commercial solutions, commercial services on top of them. And even more so, we actually help them promote whatever it is that they build commercially on top of our open source projects. And you will hear, like I said, a few times about Bosch today and what they are doing in the IoT space. And I think this is really showing like why open source matters, I guess, in all kinds of industries, but in IoT in particular. So this is a quote, I think, from 3 years ago, I would like to say, from Mr. Stefan Ferber, who is now the CEO of Bosch Software Innovations, so the software division of Bosch. And well, back then, and I think it's still true today, there were hundreds of IoT platforms out there, and there probably still is, right? Platforms for like device management, for data analytics, all things IoT, AI, whatever. And well, there's really lots of fragmentation. And for a company like Bosch, that doesn't quite work because they have billions, like they literally have billions of devices that they want to be able to connect. And so what's their options? They can either try and work with a particular vendor, and I won't name them, but you know them, like the top 3 platforms out there. They can work with them, but it's kind of a risky business to possibly like bet their multi-billion-dollar business on top of a particular vendor and not necessarily be owning like the pricing model, owning the roadmap of the platform software-wise. So that's an option. Another option is, well, they are Bosch, so they can build everything in-house, right? And that could work too. And what's the risk? Well, the risk is probably interoperability. Like if they build something in-house, this might not be necessarily interoperable with other solutions, with other existing standards out there. So what they decided, long story short, is they want to build their own platform, if you will, but it's not their platform, it's going to be an open source platform. So Bosch, for the past 3 years or so, are actively driving the development of an open source IoT platform under the umbrella of the Eclipse Foundation. Eclipse brings them the the governance model, the intellectual property management, and brings them a way to really engage with a wider community and make sure that whatever platform they will end up building together with the rest of the ecosystem is going to be a platform that actually is used in the industry. So our member companies like Red Hat, in addition to Bosch, like Red Hat, IBM, Intel, Sierra Wireless, many others, they collaborate really on the building blocks in terms of software that are required to build an IoT solution. So all the way from like embedded devices to IoT gateways to the cloud services, if you will. And so they collaborate on the technology, but beyond that, and this is where the open source foundation side of things really starts to kick in, is that we help with like the collaboration models, helping companies figure out, there's no way to build an IoT solution or an IoT ecosystem alone. Even if you're Bosch, you need partners. You need partners in terms of data analytics. You need partners for your hardware strategy. So what does it mean to have an ecosystem and business models around your open source building blocks? Well, that's what we are trying to help our community achieve, right? So diving a bit into what it is we actually do, first looking maybe more at the technology side of things. There's close to 40 actually open source projects, and today, like I said, you're going to learn about some of them, about Eclipse PAHO for all things IoT communications using the MQTT protocol. You're going to learn about fog computing with Eclipse IOFog or Eclipse Fog OS. You're going to learn about modeling, about device management, digital twin. We have essentially all the building blocks that are required at one point or the other in an IoT software stack. I would like to say that we have a solution and one or more open source projects there. So yeah, 37 open source projects, which means that there's lots of code available, lots of R&D that's already there for free, if you will, right? Like free as in beer, like you don't need permission whatsoever to start using our open source projects. Hopefully at some point you will use the project and contribute back in a way that's also like what free means. You are able to adapt the technology to your needs, and if you feel like whatever changes you've done to the open source project may benefit to the ecosystem at large, you may decide to contribute back, which lots of people do. We have that will be for the last 12 months. If you look at how many people contributed code and bug fixes and documentation improvements and so on to our projects, it's 350 plus contributors, and there's lots of community engagement, right? If you look at our website, which is one vanity, I guess, metrics among many others, there's lots of people who look at what we do, and I guess that's kind of partly for historical reasons. The Eclipse community has basically a background into building tools for developers, and so we have lots of developers that are already part of our community, and lots of developers, whether they come from the automotive industry or whether they build aircrafts or one way or the other, those are people who start looking at IoT use cases, and they start looking at what's happening in the Eclipse IoT community. So we have, I think, 45, 46 member companies to this day. If you are, at the end of today, if you're interested in talking about what it means to be part of our community, I'd be happy to chat with you. Yeah, just we'll dive a bit deeper into kind of the different personas, if you will, of the kind of companies who engage with our community, and you will see that even if you don't necessarily directly contribute and work on the open source projects, there might still be value in being part of the ecosystem at large. All right, again, technology-wise, what are we looking at? So I think it's exactly 2 years ago that we worked on a white paper called The 3 Software Stacks Required for IoT. And by the way, so our logo happens to be also our website, in case you didn't realize, so iot.eclipse.org. Please go there and check out all our resources, and there's quite a lot, actually, including this particular white paper where one thing we try to do, and I know for some of you this might be or feel oversimplified, but that's certainly on purpose, that we try to really look at a very high-level overview of what a typical IoT end-to-end software stack or software implementation, if you will, looks like. And usually in most of today's use cases, you would have constrained devices. So when you talk billion of devices in IoT, that's like where the billions of devices are. Those battery-powered, pretty constrained devices where you need to make choices in terms of what protocols you want to use to communicate. There's just no way you're going to be able to talk HTTP and MQTT and CoAP and whatever else. You need to make choices. You need to make choices in terms of there won't be lots of space for running very complex applications. There won't be lots of space for having like a complete SDK, complete application framework. So what does it mean software-wise? We'll look into it, but like at a minimum, you are looking at a software solution that will allow you to update your devices remotely. Otherwise, like you don't really own your device. If you cannot really update it, you cannot really secure it. So what is available in that regard, we'll look at that. And yeah, in lots of solutions, you see at one point or the other your edge gateway, right, which is more capable than a constrained device, might be very likely mains powered, right? You have plenty of room, or at least enough room for running an actual operating system, as opposed to no operating system at all, or some kind of real-time constrained operating system for your constrained devices. And yeah, you have really more room, and probably, yeah, you will have some kind of application runtime that really allows you to run several applications and do like edge analytics kind of stuff where you can maybe consolidate the data at the edge. You collect data from your sensors, collect all the data onto your gateway, do some local processing, local like data analysis, and then you push your data to your cloud. And then what's in a cloud? What's in an IoT cloud? Well, chances are it's your good old cloud in many ways. You want a database in a way, right? You want to have some kind of dashboard to monitor what's happening. There are a few services that make your IoT cloud IoT specific, right? Typically device management. What does it mean to manage your device inventory? What does it mean to have APIs that are sort of IoT aware? And by that I mean basically digital twin, right? You want to have something that's as close as possible as the representation of the asset that you want to interact with on the cloud. And obviously you want to leverage whatever PaaS, whatever platform as a service solution are out there, like Kubernetes and so on, so that you can scale your IoT platform horizontally, most likely, right? The more data you want to ingest or you need to ingest in your backend, the more you want to scale, right? Ideally, maybe auto-scale, right, your solution. So what's in there, we'll look at that as well. So yeah, 3 stacks. And so by stacks, I mean just like the LAMP stack, I guess, for web development, right? There's new and more modern things than the LAMP stack these days, right? But Linux, Apache, MySQL, PHP is something that made the web really successful, right? Probably almost 2 decades ago now, I guess, where essentially not only is this an open source stack, but it's some building blocks for having like a programming language and a programming framework for building your web applications, a database in the form of MySQL, an actual web server in the form of Apache, and altogether those building blocks, you can easily put them in the hands of a developer and they will be able to start developing right away, right? And so what does it mean for IoT? Can we get to the point where we have similar stacks for constrained devices, et cetera, and are such stacks available at Eclipse? So one thing that I wish we had, but quite frankly, this is not our focus at Eclipse, and I want to actually give a shout out to other communities out there, in terms of stacks, like sort of ready to use SDKs, if you will, for constrained devices, we don't really do that at Eclipse. We have building blocks that can help with device management. I don't know if some of you are familiar with the lightweight M2M device management standard, but we actually have the Eclipse Wakayama project that provides like just the very building block that you need for just that. We have Eclipse PAHO for MQTT communications. That's also one building block that you need for your IoT constrained device stack. But that doesn't quite cut it, right? You need at some point some kind of ready-to-use package where you also have an actual operating system, or some form of operating system to put on top of your silicon, basically. You want to have an application framework for being able to easily build applications that are somewhat portable, and that's exactly what those open source projects out there do, like ARM Embed or FreeRTOS, now Amazon FreeRTOS, Riot, Zephyr. So those are open source stacks for IoT constrained devices. The good news, though, is that many of them, if not all of them, they are actually repackaging the projects, the Eclipse projects that I just mentioned, Eclipse Wakayama, Eclipse PAHO. You would actually find them into in those stacks, which is, I think, quite nice. Gateways, that is one of our focus and one of our strengths, pretty much since day one. So what is an IoT gateway in the first place? Well, the way I usually describe it is that it's some kind of router, like good old internet router, if you will, and like one of the roles and the duties of your gateway is to provide connectivity to your assets, right? You have sensors, like, I don't know, Wi-Fi sensors, Bluetooth low energy sensors, maybe like even PCs and laptops that are part of your IoT local network, if you will, of your shop floor, for example, and you want those assets and devices to be able somehow to get internet connectivity. So yeah, good old internet router. But what's more, you want the gateway to be somewhat programmable so that you can put some logic at the edge where not only will you sort of transparently route some internet packets, but you will be able to actually be smarter. And like if you are talking to BLE sensors, maybe what you will want to do is query data like every second or so, and then consolidate the data at the gateway level so that whatever information you push to the cloud will already be pre-processed, will possibly make the best use of the bandwidth that you have available. If your gateway is using a cellular link to talk to the cloud, well, you might want to be careful. If you have thousands of sensors on your shop floor, you want the gateway to actually do some filtering and that kind of stuff. So you can look at a software solution like Eclipse Cura, which is basically a software stack that you can deploy on virtually any operating system, Linux or Windows, or like any kind of Yocto-based distro. And what Cura provides you is really all the routing, wireless router stack, just like OpenWRT, if I were to be very, very specific. But what it adds to something like OpenWRT is really an application framework. So what does it mean for me to actually deploy my own software onto the gateway? Well, I need APIs to interact with possibly the GPS, if the gateway is embedded in a car or in a bus. I need APIs to interact with all the sensors and all the GPIOs that might be on the gateway. I need APIs to talk Modbus, Bluetooth Low Energy, CAN bus, OPC UA, if I'm more looking at the industrial IoT side of things. So all those APIs and all those libraries, if you will, they are part of the Eclipse Cura package, right? So you just deploy Cura onto your own custom gateway, or you get an off-the-shelf gateway that already has Cura on it. And what you have basically is a complete application framework where you can start deploying your own apps onto the gateway. And better than that, you have a remote management API that allows you, like I said earlier, like to manage the software that's running on your gateway, to manage it over the air, to manage it remotely, right? So that's what Eclipse Cura does. It's 100% open source. You can either take it, like I said, as it is, or like maybe get some off-the-shelf gateways, or you can start like improving it if you want to add new protocols that might not be part of the default distribution. You might want to do that, right? If you're looking more at, it's kind of more a, I guess, a vertical that you may find and you may be interested in if you're looking at smart home use cases. The Eclipse Smart Home project actually addresses all things smart home. So what does it mean to model rules like if the temperature in my bathroom goes above a particular threshold, I want to send an SMS to whoever, things like that. So this is essentially what the Eclipse Smart Home framework does. It's a very popular open source project. And there's lots of distributions out there that make use of Eclipse Smart Home as the underlying runtime. One being OpenHub, which also happens to be open source. And beyond OpenHub, there's also an actual commercial solution driven by Deutsche Telekom in Germany and now Orange as well in France. They actually build white label home automation boxes that are already distributed in thousands of households all over Germany and soon in France. So I think it's a pretty big deal actually to see commercial adoption for Eclipse Smart Home. And obviously there's also commercial adoption for Eclipse Cura. And last but not least, on the technology side of things, some building blocks that you require for your cloud stack, if you will, for your cloud side, the cloud side of the IoT solution. So yeah, storing your data is important. Having APIs to access the data, sure, that's what everyone cares about. At the end of the day, this is where the value is in IoT. You want to be able to access the data coming from your sensors and to have meaningful data made available. But before that, what makes IoT very unique, and I think also what makes Eclipse IoT very unique, is that we have a solution for all things device management, which is kind of a big deal in IoT. When you start deploying gateways and constrained devices in the field, how do you keep those devices up to date? Or not even like talking about deploying new features, but fixing bugs. Like if there is a bug in the gateway that you've started deploying in like in thousands of shop floors across the country or across the world, you don't want to send a technician with a USB stick or a serial cable to update the software and the firmware that's there, right? So two solutions available at Eclipse for device management. One would be Eclipse Leshan, and that's something that's used already in production and already for managing like literally millions of devices by Sierra Wireless, Samsung, and Bosch. So Eclipse Leshan is a server-side piece of software, a service, if you will, for managing and deploying software upgrades to edge devices, and very likely, or at least historically, to cellular modules like 4G, 3G, LTE modules using the lightweight M2M standard. And so, yeah, Leshan is something that's already part of the Sierra Wireless commercial cloud. It's also used by Samsung for Arctic. It's also used by Bosch for their devices. And that's really like, yeah, providing all the stuff for keeping your firmwares up to date, for monitoring the battery level of your devices, for being able to completely wipe the contents of a device if it gets compromised, all that kind of stuff. It's based on a standard, an open mobile alliance standard, and that's Leshan. And beyond Leshan and beyond lightweight M2M, there's many ways to do device management, right? Some devices out there might be 10 years old routers that use TR069 as the standard for device management. Some of them use FTP, kind of like old protocols for deploying and downloading firmware upgrades. But at the end of the day, you might have thousands of those, right? And so what happens when you want to roll out upgrades? How do you manage the complexity of your device inventory? How do you manage the complexity of I have 1,000 devices, they are running firmware A, and I want to take them to firmware version B, and like, how do I roll out my gigabytes of firmwares so that I don't kill my network, so that I don't break my devices all at the same time? If I actually start pushing a software upgrade that has a bug, well, something might be wrong if I actually update all the devices and they just go silent because I just bricked them. So Eclipse Hawkbit really allows you to roll out your software updates progressively, to figure out, like, have fancy pie charts on your management dashboard so that you can figure out if you need to maybe roll back a software upgrade campaign that's going to go bad. So that's also open source. And it's actually a really nice piece of software, and I think you might actually hear a bit about Hawkbit later today. And those are like, I mean, device management is just one aspect, right, of the IoT services that you need to in your software, in your cloud solution. And at some point, you will need more than just device management, right? What is your solution for ingesting the data into your backend? How do you make sure that, again, you have like possibly thousands of devices, brownfield devices that talk OPC UA, MQTT, all flavors of HTTP and whatnot? How do you make sure that you can ingest all the data in a way that scales into your backend and in a way that doesn't add complexity? The more protocols you have, the more complex you would think building actual IoT applications is going to be, except if you have, unless you have something like Eclipse Hono, which is all about abstracting out the complexity of connecting devices to your, and ingesting telemetry in your IoT backend. So there's certainly the equivalent to Eclipse Hono in the commercial platforms that are out there. So XXX Hub is essentially the same as Eclipse Hono, except that Hono is open source and is something that you can deploy on your own private cloud if you need, on your own hybrid cloud, and you have really an open source solution where, should you need support for another protocol that might not be part of Hono by default, well, you can easily add that, right? And so Hono, Leshan, Hawkbit, you start looking pretty good in terms of ingesting the data, doing device management. At some point, you will want an API that actually allows you to easily build your IoT application. And like I said earlier, having some kind of digital twin and a representation of your physical assets will really help in that regard. So Eclipse Ditto addresses just that. And at the end of the day, you end up with lots of services. And again, if you're familiar with Amazon or Azure or those kind of platforms, you know that there's usually lots of like building blocks that are available for doing one thing, one very specific thing. But what is the integration point? How do you make sure that you have a common understanding of what is the identity of your devices? Where does, like, do you have a common, can you have a common database for storing all the data, all the metadata for your devices? So that's where Eclipse Kapua comes in. So Eclipse Kapua is essentially the name for the integration platform. So providing a common web like dashboard, a common set of federated APIs so that you can actually start thinking about, beyond building blocks and services, you can actually start thinking about a complete platform, a complete stack that you can deploy on like state-of-the-art paths, like just straight Docker or Kubernetes or Cloud Foundry, and really have a solution that can scale and that you can easily manage and orchestrate, and that you can easily combine with the other services that you may have deployed in your organization, right? Yeah, so that's for the technology. And now I wanted to, and I never know like what should be the flow in that particular presentation. Should I talk about the technology first or about the ecosystem? But yeah, let's talk about the ecosystem and what, on top of those projects and on the technology that I mentioned, what do people actually do? And more specifically, what do companies actually do? You would have companies like the likes of Bosch or Siemens who are like for them, and like I said earlier, and Bosch is a pretty clear example of that, they need a standard solution for connecting all the things, right? And especially in the context of industrial IoT and Industry 4.0, what is the best way to achieve interoperability and to make sure that everyone across the supply chain shares common understanding of what protocols should be used, what APIs, what software solutions should be used for connecting devices, and even more so, what should be made available so that people have the freedom to either use public cloud offerings for managing their IoT stuff, or have the ability, which is really important in an industrial context, have the ability to run the platform locally, right? And so that's why companies like Bosch or Siemens collaborate on things like Hono and all things Kapua and so on, so that there's a good solution for having a modular open source IoT platform. Then you would find software vendors like the likes of Red Hat or Ubuntu, who provide either operating systems or middleware that one way or the other will distribute and will repackage some of the Eclipse IoT technology, some data analytics or database vendors like Influx Data, Cloudera. For them, they need to have a way to maximize the number of the number of ways for people to feed data into their solutions. And so for them, it's important to have good open source implementations of the IoT protocols that matter, and making sure that they integrate those protocols into their solutions for, at the end, being able to provide commercial services, right? And SLAs, if you will, for the operating system or the database that will leverage some of the Eclipse IoT technology. And usually the way they demonstrate how they can actually achieve that is by means of test beds, which I will come to in just a couple of minutes, actually. Hardware manufacturers, I mentioned Sierra Wireless, Samsung, Intel, Eurotech are also very active in the field. How can they provide an open solution for their customers to be able to easily keep the software that's running on the silicon up to date, right? And it's really important that when you're a Samsung or a Sierra Wireless or Intel, when you sell a chip to someone, you don't want to have this someone to be bound to using your cloud platform to remotely manage the over-the-air upgrade, firmware upgrades and stuff like that. There needs to be some good open source and open standards implementations, and that's why they are basically all pretty interested in lightweight M2M, for example. Telcos, I mentioned the likes of Orange and Deutsche Telekom. All things interoperability, and they are like telcos, one way or the other, they deal with us as sort of end consumers, right? They have boxes in our house and they want to find ways to generate more value out of those gateways, or what they would hope would be IoT gateways. So home automation use cases are certainly very important. We have IT shops that provide all things support and services and consulting around our technology. And we do a lot with research institutes as well. And some of you in the room might actually be coming from a research background. And we are actually involved in many research projects. And I would love to talk to you if you have some research projects where you think bringing in some open source technology would be useful. And we can talk about that for sure. So we have technology. Yes, I mentioned the technology. We have lots of vendors involved, and so what do we do beyond just helping those guys collaborate on the open source software? Well, one thing we do is lots of evangelism in terms of educating the industry with regard to what are what is the kind of software that needs to be built for IoT to be successful. And like you've seen the white paper and sort of the architecture, if you will, with the 3 stacks that I mentioned earlier. This is one thing that we do, like help sort of, yeah, again, evangelize and communicate about what we think are like the important trends in IoT. One way we do that is also by means of what we call virtual IoT. So I know that the local meetup scene here in Singapore is actually very active. We have our own meetup, except that it's a virtual IoT meetup, which means that every other week, basically we do webinars. But we actually have a page on meetup.com. Feel free to subscribe if you're not already. And basically every other week you have a webinar, which I think would be hard to watch live because we do it at 5 p.m. Central Europe time. So yeah, this is way too late for watching it live, but it's recorded. I think that's a great resource to learn more about all things IoT, all things open source IoT. We do hackathons, online hackathons. We call this the Open IoT Challenge. We are going to start the 5th edition in just a couple of weeks. You might want to look for that one. If you want to get some cool prices and get your hands dirty into Eclipse IoT technology, that's one way to do that, certainly. We run, every year we run a developer survey where we try to understand what people are actually doing in IoT. And if I have a few minutes left at the end, I might actually go through some of the results from this year. And then, I guess the second row is more about how do we enable companies to actually be successful with our technology. The first row would be more about like being pretty vocal about what we think are the relevant standards, the relevant open source projects. Here, we are looking at testbeds. Testbeds is essentially how can we build with our member companies demonstrators that really address the end-to-end, like an actual IoT use case and showcase how from the embedded device to the cloud, how you can actually use open source technology to build a real solution. And where does open source stop and where do you need to start possibly partnering with people that can help you? Because again, there's no way anyone is going to build IoT alone. I mean, you can certainly try, that might actually be your business case to specialize on like a particular aspect of IoT, and this is where you might want to generate some value, but at one point or the other you will need partners, and that's what we try to illustrate. When you use Eclipse IoT technology and any open source technology really, you want to have an easy way to consume the open source technology in a way that sort of fits into your release engineering and software engineering existing processes. Like you will, like I said, probably get some software for free, but like how do you make sure that you can actually easily like reuse that as part of your existing software stack? That's one thing that we're trying to help the community with by means of formalizing, if you will, the way we manage all the releases of our open source products, if you will. And this is a work in progress, basically, and I'm happy to chat more if you have any questions. The marketplace, say you are working on a super unique protocol that's very bandwidth efficient for low power kind of devices. One thing you may want to do is provide some kind of plugin for, maybe for Eclipse Cura, right? And you want to distribute and make sure that people easily have access to your plugin. We actually have a marketplace where people can make plugins available for our projects, Eclipse Smart Home plugins, Eclipse Cura plugins. And I think this is a really good way to grow an ecosystem around a particular open source project, because the plugin might very well be a commercial plugin, but you can leverage our existing channels to publicize and promote the plugin. A few more words about the testbed. So like I said, a demonstrator, you want to, like, we're still at a point where many people don't really know, like, they know they want to do IoT. They're just not really sure what's their actual business case. They're not really sure what's really involved in terms of, well, software for sure, but in terms of, just in terms of partners, like you will need, like do I need someone to help me with my data analytics story? Do I need someone to help me with sourcing the right hardware? And what's my business case in the first place? So again, you can go to our website, and we have 2 test beds to date that are, one is focusing on asset tracking management. So say I'm FedEx or UPS or DHL, and I want to be able to see where my parcels are, or I want to be able to tell my customers where the parcels are. So what does it mean in terms of sensors? What sensors do I need to put onto the parcels, or do I actually need sensors? What kind of gateway do I need to deploy on my trucks? What kind of software do I need on the gateway, et cetera, et cetera? And what's the vendor ecosystem like in that particular field? So we worked with Red Hat, with Samsung, with Eurotech, with Azul Systems to essentially build an end-to-end demonstrator that you can not only try out. We have like a demo that's running on our website, but beyond that, we actually make available the blueprint, if you will, and the code, the open source code for this particular demonstrator. So you can actually see all the pieces of the solution, and you can also see where open source stops. Like we provide a demonstrator that has some features in terms of data analytics, etc. But if you require more, maybe you will want to talk to one of those vendors that can help you go further in terms of data analytics. Or as opposed to running the demonstrator on a Raspberry Pi, you may want to talk to, say, Eurotech or to, say, Samsung to get like actual ruggedized and off-the-shelf gateways that you can deploy on your trucks or on your trains if you're transporting your parcels by train, right? Industrial IoT, what does it mean to manage the performance management metrics for a particular piece of industrial equipment? Again, what's required in terms of software, what's required in terms of standards like OPC UA or like PPMP, which happens to be also a standard that we use a lot at Eclipse IoT. Check it out. There's again all the code is available from our website. And I'm basically going to reach slowly the end of the presentation, but that's not it. And obviously, IoT is quite a moving space. Like I said, the 3 software stacks. This is something that I think we put that together exactly 2 years ago. I still think this is kind of like the de facto standard architecture for IoT. Constrained devices, they don't necessarily have internet connectivity, so one way or the other, you have an edge gateway, some kind of router providing the connectivity, the edge analytics capability, etc., and the cloud. But you hear more and more, and you will hear today as well about fog computing, right? How do we kind of make this edge gateway kind of line blurrier? Like, how can we think about IoT more in terms of, I want my things to provide some capabilities in terms of, like, some things might be able to provide a data storage capability. Some things might be able to provide machine learning, AI kind of capabilities. Some others provide network routing capabilities. And how do I orchestrate all that in a more abstract and foggy way, I guess? And how do I basically start bringing the cloud closer to the edge? And that's also one way to read or to translate fog computing, right? That's basically the cloud brought closer to the edge. Eclipse Fog OS is a new project that joined recently. We also have, like I mentioned, Eclipse IO Fog, not showing up there because it's not new, but it's actually going to be covered today by Kilton. We're very happy to have Kilton in the afternoon talking about Eclipse IO Fog. There's lots of consolidation in terms of IoT standards, but there's also lots of areas where there's innovation happening. for all things industrial IoT, there's the Cyclone DDS standard that's used for building a scalable and time-sensitive network kind of data grids. So we have an open source implementation of the DDS standard. There's Sparkplug, which is a specification for making MQTT more suitable for industrial IoT use cases. So you can check out Eclipse Tahoe. The W3C is really active around the Web of Things standards. So how do you basically replicate what made the web successful in terms of REST APIs, basically, but how do you make the REST paradigm more suitable for constrained devices and for IoT? That's what Web of Things is all about, and we also have an implementation for that standard. There's lots of things driven by Siemens in that area. And of course, AI is going to be the next big topic, or if it's not already. I guess I should have blockchain on that as well. We just don't have any blockchain topic or projects just yet. But AI is certainly a big topic, and I think one thing that you may want to check out is Eclipse Deep Learning 4J. Of course, like you hear about TensorFlow pretty much all the time when it comes to doing machine learning and AI using open source technologies. But with Deep Learning 4J, I think we have an interesting solution for people looking at deploying deep learning and machine learning models and solutions in existing solutions. Basically, the main difference with TensorFlow is that Deep Learning 4J leverages the Java virtual machine, which means that you can more likely deploy it in existing like enterprise systems. And yeah, I think that's an interesting project. And performance-wise, it's actually also pretty neat, actually. So yeah, I think that's basically what I had. Again, this is our website where you can find lots of resources in terms of the recordings of all the virtual IoT meetups that I mentioned, all the white papers. Like we don't only have we not only have the 3 stacks white paper. We also have something about industrial IoT. We have the testbeds. You will find pointers to all the open source projects, and you will also find, should you be interested, this guy, the results of this year's developer survey. I said that I would talk about it if I have time, but I don't. I think I would like to keep the last minutes that I have left, or at least the last minutes before switching to the next speaker to answer any questions you may have. Thank you. Questions? Yes, and I'm going to bring the mic so that we can...
Oh, thank you very much, Benjamin. My question is about, you're using the Red Hat stack. So I'm just curious, why are you not choosing like Debian? Because the other thing that you were talking about is Ubuntu. So they are, you know what I mean? Yeah. Why Red Hat? Because they are industrial, I know, but wouldn't it be a preference to choose either Ubuntu or Debian? Thank you.
So that's a really good question. So one way to answer that is that we are actually pretty operating system agnostic, right? So like pretty much all the software that I mentioned, Eclipse Cura, Eclipse Tahoe, like you just need Linux basically to run them. Then when you move to the cloud side of things, it's true that like we do a lot around Kubernetes, for example, and so Red Hat is very active in that space with OpenShift, right? So deploying the cloud bits on top of OpenShift is actually pretty straightforward. But yeah, your question is more about like maybe I guess on the gateway side of things. Yes. Right. Yeah. Yeah. Well, so usually what happens is that our software ends up being picked up by communities or vendors when they start being interested. So it turns out Red Hat is interested very much in the cloud bits, so they are making sure that they run well, again, on top of OpenShift, and therefore Kubernetes. And for the gateway solutions, things like Eclipse Cura, they're actually packaged as Debian packages, so like anyone in the Debian community can easily use them. But it's also packaged as Docker containers, so people would just want to like build on top of one extra level of abstraction can do just that. And what we see, and I think actually our next speaker is going to talk about all things MQTT, we see people from like all kinds of, like from Fedora, maybe doing the packaging as well, people from like Ubuntu, like you said, and yeah, it ends up being either individual who care about making sure that the software is readily available in a particular distro, or it might be a particular vendor that helps drive and make that happen. Yeah. Other questions?
So at EclipseCon France earlier this year, Simon Phipps made an interesting observation, I thought, that I hadn't really thought about before, which was without the existence of open source software, that many of the cloud platforms that we rely on today might find it difficult to exist, because if they were all built with proprietary software, even managing the licenses for, say, Kubernetes and all the other infrastructure software might be a real nightmare. So do you think that Eclipse IoT could do the same for IoT cloud platforms?
Yes, and I think when you look at, I actually should have put a slide about that, but if you look at, even at the commercial, to your point, like at Google Cloud and whatever they do around IoT and whatever IBM is doing with Watson IoT and Amazon, etc., when you look at the SDKs they provide for helping people connect devices to their platform, they actually end up promoting open source as well, because, for example, when they provide some form of MQTT connector, it's actually usually built on top of Eclipse PAHO, on top of an open source stack, right? And what it means is that, well, for the commercial vendor, it means they don't have to reinvent the wheel, and it also means that they probably can leverage a bigger pool, if you will, of developers, because basically everyone is already familiar with MQTT on one hand, and very likely with Eclipse PAHO as well, because that's basically kind of the de facto standard open source implementation out there. So yes, I think open source is literally eating the world. Yep. One last question before we switch speakers. Yep.
Thank you. And my question, what about the documentation to these open source Eclipse products? Is it not enough documentation or not, or what can you tell about it? Because you know, for developers, documentation and examples is a very important thing. And as for me, I had an experience working with Microsoft Azure IoT stack, and their documentation was brilliant, I think, compared to many other things. What about your documentation?
Yes, documentation. So documentation in open source projects, I guess there's many ways to look at it. So there's several projects, and many actually projects at Eclipse. I would like to think and to say that they have fairly good documentation. If they don't, it boils down to people like interested in the technology. Like I said, the technology is free in a way, right? It's free as in free beer. You can get the technology for free. Many of the projects, especially I think like in the device management space, our digital twin solution as well, they might not be feature complete just yet, or they might not be complete just yet in terms of documentation. So one way to help grow the community and make the project more successful is provide feedback, right? You don't have to write the documentation if you feel like it's not your duty, but if you feel like something's missing in the documentation, it's certainly your duty as an open source user or an open source interested party to provide feedback, right? And all our projects would very much welcome any feedback in terms of, hey, you know what? You think your thing is interesting, but right now I'd rather use Azure IoT because yes, it's commercial, but at least they have a better documentation, right? But it's always kind of chicken and egg. I think it's important to identify when you build an IoT solution or an IoT application of any kind, to identify where you think your actual value add is, and then to figure out whether it makes sense to just go the Azure IoT route because it's going to be simpler, and yes, there might be some risks in that. Well, you don't really own the pricing model, you don't really own the roadmap, etc. And if you feel like a particular functionality is something that you want to own, you will want to look at open source, and yes, it might mean starting by just consuming, but then figuring out that the learning curve is maybe a bit steeper, but maybe you will end up writing documentation internally for your own team, and maybe you will realize, hey, you know what, this documentation ought to be shared with the community at large, because I think this is a really neat piece of technology, and I'd rather have more eyeballs and more people working with me on making this a success, because I'm actually now depending on it for my business, right? So I hope it answers the question, but be vocal and provide feedback to the projects, I guess, is the bottom line.
So, as a maintainer of an open source project, I think that's a really valuable comment. There are many different ways to contribute to open source. If you rely on it, either personally or in your company, then it's a good thing to contribute back to the communities and the projects that you use. And there are many different ways to make contributions, and contributing to documentation, for instance, is one of those. So even for a person like me, for whom it's my job to contribute to open source projects, it's still a lot of work, and you end up responding to lots of questions that people might ask in the best possible way, and there's always more work than, or more time that could be spent on the project than I have available. So all contributions are welcome, and we always need help.